So we've already looked at the beginning of the section on surfaces in space. This section is about analyzing different surfaces in 3D. Several of the surfaces we've already looked at, like spheres and planes. We then defined a new surface called a cylinder. To find a cylinder, let C be a curve in a plane, and let L be a line not in a parallel plane. The set of all lines parallel to L and intersecting C is called a cylinder. For example, x squared plus y squared equals 16. In 2D space, that is just a circle. In 3D space, the z is not constrained by anything. So this would be defined for all values of c. The curve x squared plus y squared equals 16 would exist on the plane c, and then the line L would be the z-axis that extends forever upwards and downwards. So this would describe what's called a right circular cylinder. The word right is in there because we have a right angle, a 90-degree angle between the plane C, where x squared plus y squared equals 16 exists, and your line L, which is the z-axis. We also described some different 3D surfaces which were all cylinders. The naming convention for this is you want to see what sort of graph do you have from the variables given, and then just add the word cylinder at the end. For example 2a, we have y squared plus 9z squared equals 16. We have two variables that are squared, both are positive, and the coefficients are different. This is the equation of an ellipse. So this would be an elliptical cylinder. For part B, we have z equals x squared. This describes the equation of a parabola. One variable is not squared and the other one is squared. So this would be a parabolic cylinder. Part D, we have z equals 2 sine of x. So this is a sine function, so you would say this is sinusoidal. So this would be a sinusoidal cylinder. Part E, x is equal to e raised to the z power. E to the z is an exponential function, so you would say this is an exponential cylinder. And then part F, x squared minus 4z squared equals 16. Both variables are squared. One of them is negative. That describes the equation of a hyperbola. So this would be a hyperbolic cylinder.